Hey everybody, I'm Mr. Hartzler, and I want to talk to you today about solving exponential equations. And we have to start off by setting up what that means. And we're going to have some variable b, and we're going to say it must be greater than 0, and it cannot equal 1. So if we say that that's our situation, then b raised to the x equals b raised to the y power, if and only if x equals y. That means that if this statement is true, x must also equal y. Or if x equals y, then this is also true. So some examples below I think help clarify. 3 raised to the x equals 3 raised to the 5. I just say that as true statement, true fact, then x must equal 5. Our exponents must be the same. Same thing is true over here in a little more complicated situation. If 1/2 raised to the second power equals 1/2 raised to the x plus 1, well, then the 2 must equal the x plus 1. And then we can solve for x and continue on with our lives. All right, let's look at some more complicated examples, and we'll actually work through these. So here, I have 3 raised to the x equals 27 raised to the second. Last time, both of our bases were the same, so we just pulled down the exponents. We're going to do that in this same situation. I'm going to make sure that both my bases are the same. Well, in 27, we should know that that's 3 cubed. So now I have the same base, both of them are 3's. Let's simplify a little bit further. If I have 3 cubed raised to the second power, that's power of powers, so that's 3 to the 6th. Exponent raised to another exponent, I multiply these two and get myself a 6. Well now, same base, so their exponents must be the same. X has to equal 6. Over here, 4 raised to the 2n minus 1 equals 64. Well again, let's get the same base here. So that's 4 to the 2n minus 1. 64 is 4 cubed. And from there, I know same base, so my exponents must be the same. 2n minus 1 must equal 3. And then I can just solve for n like I normally would. And n equals 2. We could have also up here gone one step further and gotten everything so it was a base 2. So that would be 2 squared raised to the 2n minus 1 equals 2 squared then raised to the third. And then we could simplify that one down the same way. But the nice thing is we didn't have to go quite that far. We could leave it at just the 4. All right, next example is actually more of notes, more of like notes kind of thing. So compounding interest, we have an equation for that. A, and they're all defined over here. That's our amount after our principal and our interest have been applied. P is principal. That's the initial amount that you put into an account. And then we have in parentheses 1 plus r divided by n. R is our interest rate, or like whatever kind of debt rate or growth rate or decline rate, anything like that. N is the number of compounds per year. Sometimes that's yearly, sometimes it's monthly, quarterly, daily. It depends on how your bank works it. Depending on the account, they're different. I have some that are compounded daily, and I have some that are compounded quarterly. So it just depends on where you're at. N appears the same N, so it's still the number of compounds each year. And then T is number of years, so our time. Then we have an investment account pays 4.5% annual interest compounded monthly. If $3,500 is invested in the account, what will be the balance after 15 years? So let's start substituting some stuff in. I don't know my amount after. I do know my principal. That's $3,500. Then I have 1 plus, this is going to be my interest rate, 0.045, divided by the number of compounds per year. Well, it was compounded monthly, so that's going to be 12. If we were compounded quarterly, well, then it would be 4. Bi-weekly can actually mean two things. It can mean twice a week or every other week, so that depends on context there. 12 times in a year and 15 years. Well, let's simplify this a little bit further. And we're looking at, still don't know my initial or my amount after. I have $3,500 going in. Simplifying within my parentheses. I want to go out as far as I can with my decimal. Well, now keep in mind PEMDAS. It says I have to use exponents before I multiply. So that 3,500 is still sitting out in front, hanging out. 1.00375 raised to the 180th power is not as big as what you think. 1.96156. Now I can multiply these two things. Don't forget PEMDAS. So we always do the exponents before we multiply. And now we know our final amount, which is $6,865.44. Awesome. So you more than doubled your money. And that's kind of nice because 4.5% isn't that crazy. They're saying right now for the stock market, you can assume over a long period of time 3.5% that you will grow. And that's after taxes and everything. So that's kind of nice. This one's done. This is compounding interest. Let's go on to this one. We're just solving exponential inequalities. So the only difference between some of the other ones and this is that's not an equal sign anymore. It's just 2 raised to the x plus 2 is greater than 1/32. So let's do the same thing we've done before, and let's get the same base. Well, that's going to be 2 to the 5th power. But keep in mind it's on bottom. That 32 is on bottom, so 2 to the 5th is on bottom. But we know how to move that to the numerator. I don't say flipping because it, I don't know, just has a bad issue of people screwing stuff up when you say flip. But when we move 2 to the 5th power to the numerator, the exponent becomes negative. Well, now x plus 2 must be greater than -5. Subtract the 2, x is greater than -7. That's awesome. Alrighty, folks, hopefully this was helpful. If it was, please click that like button that's down over in here, and subscribe to the channel if you want to see more like this. Over there somewhere, I'm going to put the video to the next, the link to the next video once that one is available. Have a great day, folks.